Hello everyone, I am Rodrigo Santa Cruz, and I will now present my work Inferring Temporal Composition of Actions using Probabilistic Automata. In order to set the stage, I want you to realize the fact that real-world human activities are often complex combinations of simple and atomic actions. Take an Olympic goal in a soccer match as an example. It can be described as a sequence of corner kick, the ball traveling, and goal. In this perspective, I propose a new task named Complex Compositional Action Recognition, which the goal is to recognize complex activity expressed as temporal ordered compositions of atomic actions in videos. Borrowing ideas from computational theory, we propose to express compositional actions as regular expressions of subset of primitive actions, which we name action patterns. We start by a predefined small set of no simple and atomic actions A, which we call primitives. And we define our alphabet sigma of symbols W as all subsets of primitives in A, here denoted as the power set of A. Then we can describe complex actions as combinations of these symbols and the regular language operators O, such as concatenation, to express sequential actions, alternation, to express alternative actions, and clean star to represent recursive actions. It's also important to mention that more complex operators can be created from the mentioned ones. For instance, one or more repetition operator is just a followed by a star. As an example of this formulation, we can describe the compositional action driving and talking on the phone or to someone happily just after getting to the car as the following expression, using the primitive actions driving, talking on the phone, talking to someone, and getting to the car. Therefore, using this formulation, our compositional action recognition problem boils down to model a function f for a given action pattern R, such that it assigns high values to video V that satisfies R and low otherwise. In this work, we derive two inference procedures to solve this problem. More specifically, we introduce a deterministic model based on deterministic finite automata and a fully probabilistic approach based on a probabilistic automata. It's also important to emphasize that both approaches only rely on the existence of pre-trained classifiers for the primitive actions, and they do not require any extra data collection, human notation, or model fine-tuning. The goal is to provide techniques ready to be used in new real-world applications. In our experiments, we compare both approaches using real-world action recognition datasets, like multitumors and charades. More specifically, we mine different kinds of expression from these datasets' annotations, create a new dataset of expressions, and their positive and negative matching video clips, which we use to compare the proposed deterministic and probabilistic inference procedures in terms of area under the ROC curve and mean average precision. From these experiments, we would like to highlight two facts. First, the probabilistic approach works much better than the deterministic one in all of the scenarios tested. Second, consider the first point in this graph as the recognition of the simple action anywhere in the entire video, which is basically the setup for traditional action recognition. This particular case can be solved by state-of-the-art models like E3D, which performance show as a yellow diamond. The other point would require to use one of the proposed methods. As you can see, the probabilistic approach is able to extend the E3D model for much more complex expression without degenerating its performance significantly. This is a very good result, suggesting that further developments in standard action recognition models would easily boost the performance in compositional action recognition. The same two observations can be done for the results with the charades dataset. Just for illustrating our experiments, here we have two expressions mined from this action recognition dataset and their matched videos. Thanks for spending your time with me, and feel free to ask questions in the live question and answer session or via email. Have a good CVPR.